Hi and Assalamualaikum. My name is Nur Aliyah binti Abdullah. My group members are Alia Atirah and Afiqah Takiyah. So today we want to present about pH measurement in food industry. So I will pass the next slide to Afiqah Takiyah. Hi and Assalamualaikum.
Project background. First, the pH is a measure of an aqueous solution acidity or alkalinity. Second, a pH meter is an instrument used to measure hydrogen ion activity in solution. In other words, this instrument measures acidity or alkalinity of a solution. When the pH value dips down below 7, the water starts to become more acidity. Any numbers above 7 equates to alkalinity. Lastly, the pH meter also need to be calibrated from time to time. Project background. The objective is to study about the function of pH transmitter in industry. Second, to know about the advantage and disadvantage of pH transmitter. And lastly, to know how to use pH transmitter. The objective is to study scope study. First, this document describes the determination of the pH value of the water sample. Second, the determination of the advantage and disadvantage of pH device in industry. And lastly, to know the working principle of this device. Scope study. First, operating requirement. First is power requirement. Power requirement are vary depending on the type and model of the transmitter. Second is enclosure. Enclosure of the transmitter is important to consider. The application of the device will determine the size to ensure the proper function on the field. Next is input or output. Input or output can include single or dual sensor version. Next is compatibility. Compatibility of the device with multiple systems and in multiple industry is important to consider when selecting the pH meter. Next is display type. Display type is generally high contrast digital LCD screen. Next is analog. Analog system are traditional one-directional communication protocol. They transmit one variable per loop and the device must be calibrated on the device itself. Operating requirement. First is
analytical measurement and control of pH within a system is necessary for many processes. Common applications include food processing, wastewater treatment, and chemical industries. To maintain the desired pH level in a solution, a sensor is used to measure the pH value. If the pH is not at the desired set point, a reagent is applied to the solution. When a high alkaline level is detected in the solution, an acid is added to decrease the pH level. When a low alkaline level is detected in the solution, a base is added to increase the pH level. In both cases, the corrective ingredients are called reagents. Accurately applying the correct amount of reagent to an acid or base solution can be challenging due to the logarithmic characteristics of pH reaction in a solution. Implementing a closed-loop control system maintains the pH level within a certain range and minimizes the degree to which the solution becomes acidic or alkaline. An example of an automatic pH level control system is a water treatment process where lime-softened water is maintained at a pH of 9 using carbon dioxide as a reagent. As the untreated water or influent enters the tank, the pH is continuously monitored by the pH sensor. The sensor is the feedback device to the controller where the set point is compared to the control value. If the values are not equal, the controller sends a signal to the control valve that applies carbon dioxide to the tank. The reagent is applied to the tank at varying rates to precisely control the pH level. With the pH level at 11 detected by the sensor, the controller commands the control valve to open and introduce more carbon dioxide. As the increased carbon dioxide mixes with the influent, the pH is lowered in a controlled manner. Reaching the set point, the carbon dioxide flow is minimized and the process is continually monitored for variation. The effluent is the treated water that is discharged out of the tank. The process continues to provide the lime-softened water at the desired pH level.
Hi, my name is Alia Atira. In this presentation, I will present about types of pH transmitter, procedure of pH transmitter, flowchart, and also working principle. First, I will explain about what types of pH transmitter used in this video. In the video, the types of pH transmitter used is loop pH power transmitter. This transmitter is a two-wire device typically powered by a 24 VDC power transmitter or a 120/240 VAC power analyzer. This pH transmitter often include a built-in preamplifier which condition the signal coming from the pH sensor and provide a 4 to 20 mA output signal to the transmitter. Hi, my name is Alia Atira. In this presentation, next is the procedure of pH transmitter. How the pH transmitter work? So first, the first pH sensor will use electrode or wire to test the solution pH. After that, a controller process the raw signal from the pH sensor and deliver it to the transmitter. Then, a pH transmitter convert the pH of a solution into an electrical signal. Basically, a pH transmitter differs from a pH meter because it has a communication interface which can transmit data to the control system or computer. Next is the procedure of pH transmitter. This flowchart, pH measurement in industrial control, is basically on the video. In the video, it shows that the first step, water is enter the tank. The second step, the sensor will give a feedback to the controller. The third step, the pH at set point and control value are compared. If the pH value are not same, the controller will send a sign and the reagent will apply until the pH level same back. And the process will continually monitor the pH value. This flowchart, pH measurement in industrial control, is the working principle of pH measurement in industrial control based on the video. I will explain more flow diagram in this working principle. So the first step, water will enter the tank continuously. The second, the pH is continually monitored by the pH sensor, which is pH transmitter. So the sensor is the feedback device to the controller where the set point is compared to the control value. If the value is not equal between two values, the controller will send a sign to the control valve that apply carbon dioxide to the tank. The reagent is applied to the tank at varying rates to precisely control the pH level. When pH level at control value reaching same with a set point back, the carbon dioxide is minimized and the process is continually monitored again to make sure there is no different pH level value. This is the working principle of pH measurement in industry.
Okay, for advantage, it is used wide variety of application such as cheese making, pool maintenance, and so on. So the meter provide numerical value of the pH directly. So pH meter are very accurate and provide exact pH value with the help of pH sensor. And last, it help to determine how much acidic or basic any substance is. Okay, for advantage, it is okay for disadvantage. It is very expensive, and pH meter are required to be calibrated. Okay, for disadvantage, it is okay for the conclusion. To conclude, water, which is critical resource to the food industry, that has many uses. So water quality and its impacts on product and operation are often underestimated in food production system. So underestimation of water quality impact may lead to mismanagement of water, equipment operation, and maintenance issue. Other than that, it is loss of income and safety and food safety and product quality issue. Okay, for the conclusion,